Problem 2.6.8, we are given a circuit and they want us to find I sub s. The key thing in this problem is you are given the voltage with the polarity over resistor. So based on that information, we should be able to find the current, right? So V equals to IR, V equals to IR. Therefore, I equals to V over R. Now, we know V equals to IR, I equals to VR, but the important one here is we have a polarities, therefore we need to assign the direction of the current, correct direction of the current. So we can call it I sub 1. Always current goes from higher potential to lower potential, higher potential to lower potential. All right, so I equals to V over R. Therefore, we have I sub 1 equals V1, which is 5, R1 and 10K, and we have 1 over 2 milliamps. Okay, this point you have option. Okay, because we know the total current going into two parallel resistors, so we can use current division rule to find current I sub 2, for example. Or you want to find I sub 3, you can do that. And also we can combine 6 kilo ohms and 3 kilo ohms together to find, because they are parallel. Okay, they are parallel. And how do you know they are parallel? They do share two nodes. Okay, they do share two nodes, top and bottom nodes. Okay, and hey, Dr. Kim, what about 4K ohm resistor on the left side? They look like a parallel. No. Why? Well, we'll talk about that later. So you can combine 6 kilo ohms and 3 kilo ohms together, or current division rule. Let's do the current division rule first. For the current division rule, I2 equals opposite 6K over combine 1 times the total current, 1 over 2 milliamp, and that is 6 over 9 times 1 over 2 milliamp. Therefore, that is 2 and 3, 1 and 1, 1 over 3 milliamps. So I sub 2 is 1 over 3 milliamp. And I sub 2 plus I sub 3 should be I sub 1. I sub 1 equals I sub 2 plus I sub 3, KCL, right? For KCL. And let's find that out. I sub 3 opposite 3K over 6K plus 3K, the total current going into that node is 1 over 2. So 3 over 9 times 1 over 2 milliamp, 1 and 3, 1 over 6 milliamp. If you add 1 over 3 plus 1 over 6, which is 2 over 6 plus 1 over 6, 3 over 6, and same as 1 over 2. So we verify that, KCL. And if you apply the current into each resistor, we know this is 1 volt and this is 1 volt. Okay, so they are parallel, they have the same voltage. Now, let's combine 6K and 3K together. So that means 6K is parallel with the 3K. So 6k times 3K over 6K plus 3K. So 18K times K over 9K. So we have a 2K. Now, as you can see, 10 plus 2K, 12K is parallel with 4K. So after we combine this, the current I1 is 1/2 milliamp and going in that direction. And we know this is 1 volts and this is 5 volts. Therefore, there are 6 volts. That means we should have 6 volts here. Then we can find the current higher potential to lower potential. We're going to call it I sub 4. Okay. Then I sub 4 equals 6 volts over 4K. That means 3/2 milliamps. Now we can do KCL at node 1. So if we do KCL at node 1, entering 1/2 milliamp, entering 3/2 milliamp equals to leaving I sub s. Therefore, I sub s equals to 2 milliamp.